to Continuous Learning explores the shift toward adaptive AI systems capable of evolving alongside production processes. By integrating visual machine learning and human expertise, this approach enhances defect detection and overall quality assurance in steel manufacturing. Our speaker is Mr. Pablo Galán Saiz, researcher at Tecnalia, who specializes in applying AI and MLOps frameworks to industrial environments, focusing on continuous learning, visual recognition, and human-machine collaboration for quality improvement. Please welcome Mr. Pablo Galán Saiz.
Thank you. Okay, so first of all, thank you for being here and listen this presentation. My name is Pablo, as he has said. I work in Tecnalia, and if you don't know, Tecnalia is a research center here in Vizcaya. It's the biggest at least in Vizcaya and maybe in Spain. And in my case, I work in the computer vision platform, where we work nowadays more or less developing deep learning models, but always when we have involved some images. So the idea today is to go deep on how to manage the models and to know why it's a head start to use continual learning strategies while we are managing the models. For that, I also want to present the platform made by us, that it is Visual MLOps, that helps and simplifies the retraining loop, let's say, by doing some kind of wizard and allowing the non-experts in NI to retrain the models with their knowledge in the domain. So for that, first of all, I just want to present the both platforms that we have used. On the one hand, Visual MLOps, as I have said, it has been created to manage all the models of a company, but when we are related with images. And on the right side, you can see Surfin. Surfin is a system designed by us that is able to do a hot inspection of surface when we are working with bars after the rolling process. And we are here with some partners like Ideable that has helped us with Visual MLOps. And I have to say thank you also to Olarra, because they have allowed us to use their implementation of Surfin in their company. And we have used the data and the model to show you today this presentation. So first of all, what we are going to do today is a project where we are developing a model and how to continue with it. So first of all, we have to talk about the data. And we have acquired the data using the Surfin system. The Surfin system is a hot inspection system. And using it, we are able to detect some defects in the surface. So we are able to characterize the surface and check if it is good or not, etc. How does it work? It merges two different parts. On the one hand, everything related with the acquisition, the cameras, they are linear cameras, and also the light, that it is near infrared light, adapted to that cameras. And on the other hand, we have everything related with the model, and today I want to go deep in this part of Surfin. On which product it can be applied to? Mainly on hot rolled bars, because it was designed with that purpose, but also in cold bars. And the benefits are that with Surfin, we are able to do a real-time detection on the defect to check if the products are well or not. Regarding our use case today, as you know, we have used Olarra dataset. In that use case, we are always using hot condition bars in a line speed of 1.5 meters per second. The diameter is constant. And with surfing, we have images like the ones that you see at the right part of the slide, with an image resolution of 0.8 millimeters per pixel. This enables us to detect defects with a minimum size of 0.1 per 4 millimeters. In this use case, we have focused our model in learning about the cracks and the laps. There are other kind of defects, but we focus on these two. And here you can see some images with an example of this kind of defect. OK, so this is all about how to manage or how we have managed the data set. We started with the project definition, the acquisition with the system of surfing. The data curation, we consist in clean the data set, removing images with bad quality. Maybe they are blurred, or etc. It doesn't matter. And also selecting images that are representative of the domain that we want to explore. And finally, we leverage this development because there are in Olarra some experts in the domain that they have annotated the data. They have labeled the data in only one class, defect, that groups both the cracks and the laps. But when we are working with the deep learning models, the dataset is just the first step. After this, what we have done is to train several experiments, modifying the architecture of the models. And finally, we have used someone that uses transformers. I don't know if you know what it is. We can go deep later after this presentation. And we have also configured the parameters of that model. Once we have a version, we evaluate it on a test set. And we do some kind of report to check if the model is working as we expected while we were defining the requirements. If we have a good version of the model, we deploy it, we adjust it to real-time conditions. And for me, what it is the most important stage here is the monitoring. What to do once we have a model deployed, we put it in production. And I will go now deeper in this topic. OK, so what is the problem that we have seen while we were developing some different projects? We, as Tecnalia, usually train a model. We deploy it in the companies. And they, as a company, check how the model is working on their data, on their production data. At early production stages, it works pretty well. But if we wait 4 months, we will see that the system will start to meet some defects. That's because it appears kind of drift, or the model, so the model does not predict well anymore sometimes. And this finally will end in the user loss of confidence. And what we don't want to happen is that they can't rely anymore in the system, and maybe sometimes it's finished with the shutdown of the system, or they just miss the predictions. So we thought on how to solve this problem and how enable the companies to be able to retrain their models. And we designed visual envelopes with Ideable. This tool is, on the one hand, focused on the monitoring stage. This is an interface where the workers, without any expert in AI, can see what are the predictions of the models in the images that has been inferred in the model, yeah. And based on their feedback and also other metrics like the model performance or data quality, we can see and say if a model has to be retrained or not using continual learning strategies. Okay, so at the end, what we expect is not to consider the life cycle of a model like something sequential, because it's not in that way. We have to do it as something iterative, like a cycle, where, and with the production monitoring, we close the loop, and we are able to create some version of the datasets and version of the models that enables us to adapt the model to the real condition or to the current production conditions. Here you can see some questions that are important for us. It is when we should create a new dataset version, and we have to focus on the metrics that I have explained previously. Also, when should we retrain a model, because the environments in the companies are something dynamic, but it depends on the use case. Yeah, to know when do we should retrain the model. And the final question is when do we have to deploy a new version of the model? And for this, we have a kind of traffic light to see if the model is working correctly or not, depending also in the user feedback and the metrics while we are doing the monitoring of the model. So here, the conclusion is that we have to consider the life of the models like something cyclical, not sequential. Here some results based on our use case with Olarra. Originally, we trained a baseline that we called experiment 1, where we trained the model with a dataset made on 1 month. We have tested all the experiments 4 months later. And both two experiments, the experiment 2 and 3, are retraining of the first model, adding new data within the next months, the month 2 and the month 3. In the plot, in the X, you can see the different experiments, and on the Y level, you can see the metrics, for example, the R-square that determines how many defects has been detected. And what we can see here is that if we don't retrain our model, the metrics will fail, in this case, at 22%. But if we retrain the model, giving them newest data, we can adapt our model to the conditions in the product line. So some conclusions are that sadly for the models, the environments here are something dynamic. We have to take into account that changes because the images undergo changes and we have new products ideas, etc. These dynamic environments produce that if we outdate the version of the model, we are doomed because the model performance will fall, in this case, 22% compared with the test that we did at the initial part of the project. And the most important here is that the companies must or should adopt continual learning strategies while they are managing the model life cycle. What we have seen is that retraining our model, the results have risen 32%, and that using platforms like Visual MLOps simplifies the adoption of these kind of strategies by the companies and allows them to retrain the model without the need of experts, just using their knowledge in their defects or their data. And this is all. Here you have my contact. We can talk later. We have an stand right there. And in the right part of the slide, you can just take a picture of the QR and download this presentation or send to me your contacts and we can talk. And more or less, that's all. Thank you for listening. And yeah, any question? Yeah, welcome.
Of applause. Yeah? Thank you very much, Mr. Galan.
Welcome.
We have some questions for you. Regarding the adoption of AI vision systems in the steel industry, what are the main causes of failure for these systems?
More or less what I have said during the presentation. We as Tecnalia, we developed some models for the companies, and the environment is always dynamic, something dynamic. So we train a model, it works pretty well with our test sets. We can do also some reality checks, but once we are not involved in the project, the model often fails because of the drift or other problems. And more or less that is the main issue that we have, and we want to solve it with this kind of platforms like Visual MLOps that allows the companies to do this retraining of the models without the need of AI experts.
Mm-hmm. Another one, maybe you want to extend the answer. Only if not answered during the presentation, such a model deriving could be interpreted as the model should or stop learning at a certain moment, and only retrain if the external condition change. What are the reasons behind the model deriving?
Can you repeat the question?
Yeah, it's a little bit tricky. Yeah, only if not answered during the presentation, such a model deriving could be interpreted as the model should stop learning at a certain moment.
Okay.
And only retrain if the external condition change. Another one, what are the reasons behind the model deriving?
It depends. There are a lot of different kind of drifts. Sometimes it's because of the data. As the environment is not constant, there can be some kind of vibration, so the camera can fail and it can appear some kind of blur in the images. There are all kind of drift because of the products. The amount of products is not constant, so if you don't include new products in the model, it will fail when predicting with this kind of products. Other kind of drift, I don't know, I have to think now. Maybe the ones, related with the confidence of the model in their predictions, or maybe you can have different kind of defects that haven't been included while training the model, or more or less, that's all.
Fantastic. Thank you very much.
You're welcome.
And a big round of applause to him, please. Thank you.
Bye.